All right, let's talk about something we all use, probably more than we admit, those crazy, fun, sometimes way too realistic face filters. But have you ever actually stopped and wondered what kind of techno magic is happening behind the screen? Well, today, we're going to pull back that curtain and see how it really works.
I mean, seriously, how does it know where your nose is, where your eyes are, and how does it make those silly glasses stick to your face even when you're dancing around? It feels like straight-up magic, but trust me, the reality is even cooler.
So, here's how we're going to break it all down. First, we'll uncover the magic trio of technologies. Then, we'll dive into how your camera actually makes sense of a face. After that, we'll see how it builds a little digital version of you in real time. Explore why this tech is way more than just for fun, and finally, we'll peek at the tools developers use to create this stuff.
Okay, let's get right into it. That seamless experience, turning yourself into an astronaut or trying on sunglasses with a tap, that's not just one thing. It's actually a beautiful symphony of three amazing technologies, all working in perfect harmony. And that's really the heart of it. What you're seeing is this perfect instantaneous blend of three different fields of computer science. And the craziest part? It's all happening right there on your phone, usually without even needing to be online.
And here they are, the big three. A simple way to think about it is like this. Artificial intelligence is the brain that makes all the smart decisions. Computer vision is the eyes, figuring out what the camera is looking at. And augmented reality? Well, that's the magic wand that paints the digital stuff right on top of the real world. You need all three to make it work.
So where does this whole process kick off? Before a single sparkle or puppy ear can appear, your phone has to do something incredible. It needs to look at a messy stream of video and somehow find and understand what a human face is.
It all starts with two absolutely vital steps. First, the software has to answer a very basic question. Hey, is there a face in this picture? That's face detection. Once it gets a yes, it immediately moves to step two, mapping out all the important parts of that face.
Now here's a really important distinction. Face detection is a one-time thing. Yep, found a face. But face tracking is the non-stop job of following that face wherever it goes. It happens dozens of times a second, tracking every little tilt, nod, and smile. That's what makes the filters feel so locked on and real.
So how does the software actually understand your face? It does it by plotting out a bunch of key points called facial landmarks. And these aren't just random dots. They're very specific points that map to the unique shape of your face. The corners of your mouth, the bridge of your nose, the curve of your jawline.
And you're not going to believe this. The early versions of this tech maybe tracked, 60-something points. But today, advanced models, like the ones from TensorFlow.js, can track up to 486 distinct 3D points on your face. That is a staggering amount of detail being captured instantly.
Okay, so the computer now has this cloud of hundreds of little points floating in digital space. But a bunch of dots isn't a face, right? How does it turn that into something it can actually put a filter on? Well, that's where we build your digital twin.
The system takes every single one of those little landmark points that it's tracking from one moment to the next,
And it connects them all together, kind of like a high-tech game of connect the dots. And what you get is this incredible dynamic 3D mesh.
Think of this mesh as a digital skeleton of your face. Or maybe like a virtual mask that perfectly mimics the surface of your skin and all your expressions in real time. So when you smile, the mesh smiles. When you raise your eyebrows, the mesh does too. It's totally, completely synced to you.
And right here, this is the final piece of the puzzle. The augmented reality system takes the digital filter, the sunglasses, the crazy hair, whatever, and it basically pins it onto the matching points on that 3D mesh. And because the mesh is moving exactly like you are, the filter looks like it's a part of your face. It's brilliant.
But here's the thing. As cool and fun as this is for our selfies, the technology underneath it all, this real-time facial tracking, is having a huge impact in places you might never expect.
If you look back, 2015 was really the turning point. When Snapchat dropped its lenses, it took this super complex AR tech and made it available to millions of people. What started as a fun little gimmick is now a serious tool being used everywhere, and it's only going to get more integrated into our lives.
And the uses for this stuff are just wild. We're talking about virtual try-on, where you can see how makeup or sunglasses look on you from your couch. In cars, it's being used for safety systems that can tell if a driver is getting sleepy. In gaming, you can animate a character's face with your own. It's even being tested in healthcare to monitor a patient's vital signs from a distance.
And of course, there's marketing. As this quote points out, brands quickly figured out that AR filters are an incredible way to get people to interact with their products. It creates these fun, shareable moments that are way more engaging than a simple ad.
All right, for our last section, let's pop the hood open. If you're a developer and you want to put this amazing feature into your app, how do you actually do it?
Well, you basically got two choices. You could try to build the whole thing yourself from the ground up. That gives you total control, but man, it is hard. You'd need a gigantic data set of faces to train your AI model. The other option, you can license a pre-built software development kit, or SDK, which is basically a ready-to-go toolkit.
And yeah, you can probably guess which path most developers take. Using an SDK from a company like Visage Technologies or an open source model from a platform like TensorFlow.js is just so much faster and easier. All that incredibly hard work of training the AI has already been done for you. So there you have it, a pretty incredible dance between artificial intelligence, computer vision, and augmented reality. But it leaves us with this huge, fascinating question. As this technology gets even better, even faster, and moves beyond our phones, what part of our reality is it going to change next? What's the next frontier?